Hello everyone, so my name is Martin, and in this session I'm not going to show you any slides. I'm just going to show you how you can integrate with Elasticsearch using the different clients out there. Now I'm just going to start sharing my screen. Give me a few seconds. Okay, so you should be able to see my screen shortly. What I'm going to do, here locally I've started Elasticsearch and Kibana. In the very basic setup, we can start Elasticsearch just by running Elasticsearch bat file, and similarly for Kibana. No additional security setup, no additional configuration, just bare bones Elasticsearch and Kibana. Once those two are started, we can go to the Kibana dashboard at default port, which is 5601. After a few seconds, once we start Kibana, we can go to the developer console. One of the most widely used tools from Kibana that allows us to do pretty much anything with Elasticsearch. So what I'm going to do here, I'm going to create an example Elasticsearch index along with the mapping. I'm going to insert some data, and I'm going to show you how we can query that data using the various Elasticsearch clients. Now, what I do here in Kibana, we can simply do it also through the Elasticsearch clients that I'm going to show you. But for simplicity, I'm going to insert the data directly here from Kibana. So the index I'm going to create is called order data. It contains a number of fields such as description, order date, proper serial number, shipment date, quantity, vendor, unit price, excluding VAT, and so on. So this index might represent some order data that we might have. Also, as part of the settings section, we configured the number of shards and replicas for that index. As we know, it's a good practice that we plan the number of primary shards up front before the index is created, because that number here is changed quite difficultly when we start adding some data to our index. So that's a matter of good upfront planning, and the number of replicas might be changed along the way more easily. But for now, I'm just putting some defaults with 5 number of primary shards and 5 number of replica shards for my index. I'm going to execute that through the developer console. Here I can see that the index is inserted in Elasticsearch, and it's been acknowledged in my current instance of Elasticsearch. Now I'm going to add some data to that index. We have a number of ways we can use to add data. I'm going to show you just briefly 2 quick ways we can do that. First is by putting a single document in that index. So here what I do, I just call a put the index. This lowercase doc previously in older versions of Elasticsearch was the type of the document, because documents in an index were logically separated in types, but that was effectively deprecated. So now here we just put doc, and then the index of the document I would like to insert. I have a number of ways I can specify that index. If I don't put anything here, Elasticsearch would create that for me. I can also use a custom strategy to define how this index is generated, or generated through my client that I'm using for interacting with Elasticsearch. But now I'm just putting here an index of 1, and I'm putting some sample order here that is going to be inserted in that index. I just execute that, and I can see that the document is created with a version of 1. If I want to put a document with the same index, the version would be incremented. Elasticsearch provides versioning of documents, which is quite nice. Use different versions of the same document. And if I want to insert more records, a more convenient API I can use is the bulk API. So I've pre-created request that inserts a number of records in the index. And the bulk API is under the post index name bulk API. Here under different lines, I specify the different types of documents that I insert. on the first line, I specify the ID of the document that I'm going to insert, and on the second line, I'm specifying the actual data for my document. And here I'm inserting 9 more documents in my index. So if I select that and I run that index, so it tells me that for each document that I try to insert, it tells me that it's effectively created in the Elasticsearch index. Now, having inserted a number of records in that index, I can query it from Kibana, of course. So I can say, for example, get order data search and perform any search request I would like to perform. The simplest request I can do is a match all query that just gives me all documents in the index. If there are more than 10 documents, I just get the first 10 documents, and I can use pagination by specifying additional query parameters from this search request to return more documents. So here, if I execute this match all query, I can see that I get all the documents that I've inserted in my Elasticsearch index, which are a total of 10. Okay, so I've created my sample index. Now, how I can interact with Elasticsearch in that particular index through Java. So Elasticsearch provides 2 standard clients for Java, which are called low-level and high-level REST clients. They can be added to the project through the corresponding Maven or Gradle dependency. So for the low-level REST client, I need to include Elasticsearch REST client dependency. And for high-level REST client, I need to include Elasticsearch REST high-level client dependency. And it's good here that I specify the version of the client version that matches the version of Elasticsearch I use. In that particular case, I'm running Elasticsearch 750. And here for the REST high-level client, I'm using a slightly newer version of the client, which works with 750. Once I add those dependencies to my project, I can start using the client. A very brief example of how a low-level client looks like. I create a REST client instance, which comes from the low-level client dependency. It provides a builder pattern that allows me to specify the Elasticsearch hosts to which I want to execute a query. In that particular case, I specify just local hosts on port 9200 for Elasticsearch. So once I build that client instance, I create a request. A request is represented by another instance, which is provided by the org Elasticsearch client request class. I create a post request to search the order data index. And here in that request, I can call a method to set the proper body for that request. In that particular case, the low-level REST client allows me to specify bare bones JSON that is executed as part of the request. So I call the set JSON entity method, and I specify a match all query. Here, of course, we can use our own Java model in combination with Jackson or a different JSON processing library that allows me to not construct this string here as part of the JSON entity method. So that's perfectly fine to do. And once I construct this request, I call perform request method on the REST client coming from Elasticsearch, which simply invokes the request and returns the response. And the response, I process it by converting it to string and just printing it out. Again, here the response might be parsed as a Java model that I have, and I can work with it accordingly. But here I simply get it as a string and print it out. So if we run that simple enough example, just to see what happens. Once the client runs, I can see that I get the records that I inserted earlier from Elasticsearch, a total of 10. And they're returned simply as a string, so as a JSON array that I get from Elasticsearch. Now that's good, but in many cases that's not very convenient, of course, as we need to construct JSON here. For that reason, we can use the high-level REST client, which provides a higher-level set of abstractions that we can use in order to interact with Elasticsearch. we can use the high-level REST client in a similar manner as the low-level REST client. The methodology is pretty much similar and the same. So we create an instance of REST high-level client, and we specify on which Elasticsearch host we want to connect to. Then we create a search request on the order data index, which is a higher level instance class than the one provided for the low-level client. Then we create a search source builder, which in fact implements builder pattern and allows us to build the query using the various utilities provided by the high-level REST client. In that particular case, I call the query method and I specify a match all is available from the query builders class. So the query builders class is very convenient as it provides me the possibility to specify different kinds of queries using the various methods such as match query, match phrase, and different kinds of search requests I can create using query builders. So in that particular case, I just specify match all query, which is the simplest possible one. Then I set that search source builder on the search request, and I call client.search passing that search request, which is executed from the client to the Elasticsearch instance, which I have on localhost. Then I can iterate very nicely through the results. I call get hits because the results are returned under this hits block. And then I call once again get hits to return an array of all the results. And then for each result, I call the get sources string method to return the result as a string. So I'm in fact doing the same thing as with the low-level REST client, but just using the high-level REST client. Now, if I run that example, it will simply give me the same result as with the low-level REST client. So I'm getting the results one by one, and I'm printing them as strings. So far, so good. So, however, many projects that want to integrate with Elasticsearch are based on a higher-level framework, such as, for example, Spring. And if we want to create, of course, instances of those low-level or high-level REST clients, we can create our own bean method that returns an instance of any of that clients. And effectively, we can create a managed bean that corresponds to a client for Elasticsearch using low-level or high-level REST clients. However, under Spring Framework, we have a few nice projects that further simplify the process of interacting with Elasticsearch. One of them is called Spring Elasticsearch. So Spring Elasticsearch is hosted under GitHub. It's a community project, not officially under Spring Framework, but it currently supports latest versions of Elasticsearch. What Spring Elasticsearch provides is a convenient way to create low-level and high-level REST clients by adding additional capabilities, such as, for example, creating additional mappings or indexes while creating the client or adding more properties to the client. In order to use Spring Elasticsearch, we need to include, of course, dependencies in our proper dependencies in our build configuration. In that particular case, I had the Spring Elasticsearch dependency, which comes from that group, frp-latu Spring. And once I add that dependencies, I need to create a configuration class. In that particular case, I create a configuration for REST high-level client using Spring Elasticsearch. To do that, I create an instance of Elasticsearch REST client factory bean, which is the main utility provided by Spring Elasticsearch. Using that factory bean, I can set a number of things. I can set the number of the particular Elasticsearch nodes to which I want to connect. I can also set mappings, and here I specify a list of indexes to be created in Elasticsearch. For each of those string indexes, I can specify in the resources of my application JSON files that correspond to those indexes. And what the factory bean does is that it gets the information for the mapping from that JSON file and creates it in Elasticsearch once an instance of the REST high-level client is created. So that's pretty convenient if you want to pre-create some indexes or create indexes using some index templates, for example. because otherwise, if you want to do that, you have to do that as a separate initialization part of your application using those clans. So that's pretty convenient. So using that factory bin, then we call the getObject method to get the generated high-level REST client instance and use that. Once we provide that configuration, we can simply inject an instance of our REST high-level client. And using that, we can perform a search request as we showed earlier using that high-level REST client. For example, in that particular case, I'm creating a matchable query using this injected instance of REST high-level client created with Spring Elasticsearch bin factory. If I run that example, as expected, it returns the same results as using the high-level Elasticsearch client, with the possibility to pre-create additional indexes and provide more configuration as part of this Spring Elasticsearch configuration. And last but not least, a further layer of abstraction we can add is if we, for example, have already a Java model that we want to use in order to create our indexes and to query those indexes. Here comes in handy Spring Data Elasticsearch Framework. Spring Data Elasticsearch Framework provides the possibility to make use of the Spring Data methodology for interacting with Elasticsearch. In order to use Spring Data Elasticsearch, we need to add the corresponding dependencies. Spring Data Elasticsearch is an official Spring project, and the group ID which I need to use is org Spring. What I can do, I can create one model class that represents my index as a Java model. So that class is annotated with this document annotation that comes from Spring Data Elasticsearch, which specifies the name of the index for which this Java model corresponds. And then I define the different fields which correspond to the document fields of that index. I also annotate one of those fields with an ID which corresponds to the document ID, because in Elasticsearch, every document has a unique ID, as we know, and I can annotate that with ID annotation. I also have a few other, but I'm not going to use that throughout the demo. That's the very basic model I can use for my index that I created earlier. Then I can create a repository, a Spring Data repository, which should extend from Elasticsearch repository. And I specify as a first argument the model that corresponds to my index. Then I create two methods. One is find by serial number, which Spring Data Elasticsearch is able to generate based on the naming convention of that method a query against Elasticsearch that gets me all the documents that have that serial number. And if I want to create a custom query, I can use the query annotation from Spring Data Elasticsearch and specify in pure JSON what's the exact query that I want to execute against Elasticsearch. In that case, that's a match query that pretty much does the same thing as find by serial number method, but using a custom query. Now, in order to use that repository that I created using my Java model, what I can do, I can simply inject that repository as part of my application and call the corresponding method. In that particular case, I can just call find by serial number. And that's all I need to do. As you can see, it's pretty concise, but that's driven from the Spring Data methodology. And another thing I can also use from Spring Data Elasticsearch is to inject an Elasticsearch REST template client that allows me to perform operations at a lower level against Elasticsearch using that template class. So if I run that example, I can see that here there is a request performed, and I'm getting the description of the document that has this particular serial number of which I've specified here as the method argument. I can see pretty much that here document returned, which corresponds to an order for Windows 10 Pro laptop, which has that serial number. And as you can see, I didn't have to write any particular Elasticsearch query. That was done for me behind the scenes from Spring Data Elasticsearch. So that's pretty much it. To summarize, we saw how we can use the standard low-level and REST high-level Elasticsearch clients. Older versions of Elasticsearch use a now deprecated transport client, which you should be discouraged to use. And if you use Spring Framework, you can also use as an additional helper the factory provided by Spring Elasticsearch project, or go straight away with Spring Data Elasticsearch, which is the highest level of abstraction available in Spring Framework to interact with Elasticsearch. Now, we have a few minutes for questions. You can ask any questions in the chat. We've been notified of some delay. I'll just stop my screen share. So if you have any questions, just ask. Okay, there are a couple of commands that, yeah, I can use try with resources in the examples. The examples I've shown you might be improved in a number of ways. These were just very straightforward, simple examples to demonstrate how we can interact with Elasticsearch. So yeah, of course, we can provide a number of improvements there. For the source code, yes, I'll provide you with a link for that. I'll put it on under my GitHub account, so you can find me under GitHub. My account. I just need to log in shortly. You can find me as Martin FMI under GitHub, and I'll put the examples there shortly. Okay, any questions in regard to interacting with Elasticsearch, the clients that I've shown you, or any other topics related to interacting with Elasticsearch? We have 2 or 3 more minutes, so please go ahead. In the meantime, while think of some questions while we have a bit more time. So as I mentioned, it's good to keep in mind that using the different clients, you need to make sure that they're compatible with the version of the Elasticsearch or the ELK stack that you use. Otherwise, you might get into situations where even though the client might work, at some point in time, it might be a single API that performs in an unexpected way. So it's a must that you use the corresponding version of the dependencies for your deployment of Elasticsearch. And of course, there is a lot of capabilities that I didn't show you during this session, which you can explore using the various clients for Elasticsearch. And you can just play around with the clients. They are very rich. All the things that you can do in Kibana, you can also do them through the Elasticsearch clients. So yeah, I just encourage you to play around with the various clients. If you use Elasticsearch, see what would be the most convenient for you to use. So I'm going to share here my profile in the chat. I'll put the examples shortly so you can use them. Okay, I think we are out of time. So I would like to thank you for the attention. And yeah, you can catch up with me, find me on GitHub, LinkedIn, or any other means, and just ask me for any Elasticsearch related questions if you have any. I'll be happy to answer and help. So have a nice day and enjoy the rest of the conference. Bye.